Welcome to this lecture series on trigonometry. Myself, Mintu Dole, Maths faculty of Utopian Academy. As we know, as a preventive measure against the COVID-19 outbreak, all the schools and colleges are locked down. To help the student of class 10, I have prepared this lecture series. So kindly give your feedback, and since I don't have a decent equipment to do recording, you may face some quality issues in the lecture. Anyhow, follow all the lecture series, get a good concept about the trigonometry, and do well in your board exam. So without wasting time, let me start my lecture on trigonometry. Now, in NCERT text, it comes in the form of two chapters, that is chapter 8 and chapter 9. Now, the chapter 8 is named as Introduction to Trigonometry. So let me write down here, Introduction to Trigonometry. And chapter 9 is named as Some Application of trigonometry. Now let us start chapter 8. Now let us start this chapter by asking ourselves, what is trigonometry? So let me write down here, what is trigonometry? Now if I look into this word trigonometry, it is formed by combining three Greek words, and the Greek words are trigon and metron. The English meaning of tri is three, gon is angle, and metron to measure. So let me repeat again. The English meaning for tri is three, gon is angle, and metron is to measure. Now if I look into this English equivalent or English meaning of trigon and metron, it says that there is a three angles, and with the help of that three angles we are going to measure something. Now in mathematics, if I think of any three angles, definitely the triangle comes to our mind. So if I say triangle, it's any closed geometrical figure having three angles and three sides. Now in the trigonometry particularly, we are going to use a right angle triangle. The first requirement to learn trigonometry is a right angle triangle. So let me draw a right angle triangle here. So let me draw it here. Let me name this triangle as triangle ABC. Now here we are ready with a right angle triangle, right angle at B. Now in a right angle triangle, there is a side known as base and hypotenuse and also perpendicular. Now to know which one is the base and which one is the perpendicular and this is the hypotenuse. Okay, let me tell you that the longest side is known as hypotenuse. So here, if I look into this figure, here AC is the hypotenuse. Okay, let me write down here hypotenuse, and let me denote it by H. Now out of the two sides that is left here, one can become perpendicular and other will become base. Now let me say, let's say we are considering angle A. Okay, let me consider this angle A. Now if I consider angle A, I will call this a side adjacent to angle A, and I will call this side a side opposite to angle A. So always remember, if I consider this angle A, the side adjacent to angle A is said to be base. So let me write down here base, and let me denote it by B, and I will call this as perpendicular. Perpendicular, and let me denote it by P. Again, let me remind you once again, if I consider this angle C, this is the side adjacent to C, so this will become base and this will become perpendicular, and the hypotenuse will remain same. Now we are ready with a right angle triangle, so let us move further. So to learn trigonometry, we need a concept, or we need a starting concept, which is known as trigonometric ratio. So let me write it down here. Okay, let me write down here trigonometric ratios. So, and before discussing the trigonometric ratios, okay, there are some symbols that I would like to tell you. Now, an angle is always denoted by theta. If not always, but most of the time, the angle is denoted by theta. So, if I consider this angle A, now let me denote this as theta. Okay, so let me write down here. Here it is pronounced as theta. Okay, angle A. So if I say angle A or theta, it means the same thing. That means it will indicate the same angle. Now, there are 6 fundamental trigonometric ratios. Okay, so what I'm saying is that, okay, let me repeat again. There are 6 fundamental trigonometric ratios. The first one is sine theta. We call it as your sine theta. Okay, so let me write down here the first one, sine theta. Now the full form of sine theta is sine of theta. Okay, let me write down here. If I write sine theta, it means sine of theta, or simply you can read it as sine theta. Now, and the sine theta is defined as BC divided by AC. Now, if I look into this triangle ABC, here BC is the perpendicular and AC is the hypotenuse. So from there, I can say the sine theta is equal to perpendicular divided by hypotenuse. Okay, so we can simply say it is also equal to P by AC, where P is your perpendicular and AC is the hypotenuse. In the same sense, we can go to the next trigonometric ratio, that is cos theta. So the full form is cosine of theta. Okay, so cos theta is equal to if I look into the figure, it will be AB divided by AC. AB divided by AC. And if I look into this figure, here AB is the base and AC is the hypotenuse, which make cos theta is equal to base divided by hypotenuse. So it is really very simple. The sin theta is equal to perpendicular divided by hypotenuse, and cos theta is equal to base divided by hypotenuse. Once more thing I would like to tell you here, if I write sin theta, it doesn't mean the sin into theta. It is not product of sin and theta. You have to take it as a single quantity. That means the sin and theta are not separate things, they are the same thing. You have to take it as one. So let me go to the next trigonometric ratio. That is tan theta, and tan theta will be BC divided by AB. Now if I look into the figure, so here BC is the perpendicular and AB is the base. So from there I can say tan theta is nothing but it is perpendicular divided by base. Simply I can write it as a P by B. P for perpendicular and B for base. Similarly I can go to the next trigonometric ratio, that is cosec theta. So cosec theta is equal to hypotenuse divided by perpendicular, that is H by P. And the next one is sec theta. Sec theta is hypotenuse divided by base. And the last one is cot theta. Cot theta is base divided by perpendicular, that's B by P, or base divided by perpendicular. Now since I have written here the 6 trigonometric ratio, now if I compare the first 3 with the last 3, you will find that the first 3 is the reciprocal of the last 3 trigonometric ratios. From there I can say, or if I look carefully, you will find that the sin theta here it is equal to perpendicular divided by hypotenuse, and cosec theta is equal to hypotenuse divided by perpendicular. It shows that the sin theta is a reciprocal of cosec theta, or you can say cosec theta is a reciprocal of sin theta. Likewise, the reciprocal of cos theta is sec theta, and reciprocal of tan theta is cot theta. So from here you can note down few points. Okay, so let me write down here. Note the first one, since sin theta is a reciprocal of cosec theta, simply I can write sin theta is equal to 1 by cosec theta, and cos theta is equal to 1 by sec theta. In the same sense, or similarly, we can write tan theta is equal to 1 by cot theta. So here I have got a 3 formula, and I'm going to group this as note number A. So here we have got sin theta equal to 1 by cosec theta, cos theta equal to 1 by sec theta, and tan theta equal to 1 by cot theta. From here you can write 3 more formulas, like cosec theta equal to or you can also write cosec theta equal to 1 by sin theta, or sec theta equal to 1 by cos theta, and also cot theta equal to 1 by tan theta. Now let me give you note number B. Now if I look into the definition of tan theta, that tan theta is equal to perpendicular divided by base. Now here in the numerator we have got perpendicular, and in the denominator we have got base. Now you know that if I divide the numerator and denominator by the same quantity, the value does not change. So what I'm going to do here is that I'm going to divide the numerator and denominator by the same quantity. So let me divide it by h. Now I have divided the numerator and the denominator by a same quantity, that is hypotenuse. Now if I look into here I have got perpendicular divided by hypotenuse. Here I have got base divided by hypotenuse. Now we know that the perpendicular divided by hypotenuse is a sine theta. So simply I can write here sine theta. Here the base divided by hypotenuse is a cos theta. So I can write it as cos theta. So from here I can say, so let me write down here, tan theta is equal to sine theta divided by cos theta. Okay, let me give this as a 1, and since cot theta is a reciprocal of tan theta, so I can write cot theta as cos theta divided by sine theta. So these are the basic things that you have to memorize, or you have to remember if you really want to learn more about trigonometry. So before going to the next topic, I'm going to solve one problem here. So now if I look into this example, here the example says given tan A equal to 4 by 3, find the other trigonometric ratios of angle A. Now to solve this particular problem, the first thing is that we require a right angle triangle, because we can define trigonometric ratios only with right angle triangle. So let me draw a right angle triangle here. And let me name this right angle triangle as ABC. So A, B and C. Now here it says tan A is equal to 4 by 3. Okay, let me write down here, given tan A equal to 4 by 3. Now if we want to solve this problem, then we have to go back to the definition of tan A or tan theta. We know that the tan theta or tan A is equal to perpendicular divided by base. Now if I look into this particular things here, in place of the perpendicular 4 is given, and in place of the base 3 is given. But let me remind you here that here tan A, that is tan A or tan theta equal to 4 by 3, which is a fractional number. So because of that, what I can do here is that in place of the perpendicular ratio 4, I can give this as 4k, where k is any positive number, and in place of AB I can give it as 3k. Now you might or you may wonder why I have given k here. Okay, the reason is very simple. Whenever a fractional number is given, I can obtain a different equivalent fractional number for a particular fractional number. Because for example, if I multiply the numerator and denominator by 2, the value does not change. Even if I multiply it by 3, the value does not change. So to account for that, I have written here 4k, and in place of 3 I have written 3k. or you can understand it in another way also. Let me tell you that here BC is a side. So if it is a side, definitely I can call it as your length, or AB is also side. Definitely the AB will be having some length. Now if I say length or side, it will have some unit. Now if I look into here 10a equal to 4 by 3, that means the perpendicular is 4, but a unit is not given. So to account for a unit, I have given here k, and the same goes with the AB too. So account for to account the unit here, I have given k here. Okay, you can understand in that way also. Okay, anyway, both the concept are right. Now since it's a right angle triangle, here I can use a Pythagoras theorem to find out the value of AC. Once I find out the value of AC, I can simply find out the other five trigonometric ratios by simply using the definition of the trigonometric ratios. Okay, so let me use Pythagoras theorem here. So using Pythagoras theorem, here AC square equal to AB square plus BC square, and that is a hypotenuse square is equal to base square plus perpendicular square. So from here I can get AC equal to root over AB square plus BC square. So here AB is 3k square, BC is 4k square. So from here I can get root over 3k square. Now 3k square is equal to 9k square, and 4k square is equal to 16k square. So 9k square plus 16k square, it will make it 25k square, and if I take the root over, it will become 5k. From k square, 1k will come out, and from 25 it is a 5 square, so 5 will come out. So whenever you take a root over, it should be plus or minus, but here since AC is a side, so I have to take only the positive one, that is your plus 5k. Now from here I can define the other trigonometric ratios. So let me write down here AC is 5k. Now let us first find out what will be the value of sine theta. Now the sine theta is equal to perpendicular divided by hypotenuse. So here the perpendicular is 4k and the hypotenuse is 5k. Here k and k is cancelled, so it will be 4 by 5. And similarly cos theta is equal to base divided by hypotenuse, so it will be 3k divided by 5k. The 5 and k and k is cancelled, and you will get here 3 by 5. Now to find out the other three trigonometric ratios, it is very simple, because the other trigonometric ratios are the reciprocal of sine, cos and tan. So simply now I can write the third number, that is cosec theta. It is a reciprocal of sine theta. Here the sine theta is 4 by 5, so cosec theta will be 5 by 4. And next one is sec theta. Since it is a reciprocal of cos theta, so it will be 5 by 3. And the last one, that is cot theta. Cot theta is a reciprocal of tan theta, so simply I can write the reciprocal of tan theta or the tan A, so it will be 3 by 4. So here I have used the symbol theta in place of A. Because of the simply you can give here it as theta. So if I write theta or A, no problem at all. Okay, and if you want, then you can write A in place of theta. Okay, no problem at all. Let me discuss a few more concepts. We can discuss it in the form of note. So let me write down here. Okay, the first one, let me write it as here, A. Now, to discuss this particular concept, okay, so let me draw a right angle triangle here. And then let me name it as A, B, and C. And let me write down this as theta. Now here the hypotenuse is the longest side, and base and perpendicular, sometimes they may equal or sometimes they may not be equal, depending on the types of triangle. Now let me write down here sine theta. Okay, sine theta equal to perpendicular divided by hypotenuse. Okay, let me write down, this is perpendicular, base, and hypotenuse. So perpendicular divided by hypotenuse, and cos theta is equal to base divided by hypotenuse. Now if I look into the definition of this sine theta and cos theta, here we have got hypotenuse on the denominator. Here too we have got hypotenuse in the denominator. Now since the hypotenuse is the longest side, that means in the sine and cos, the denominator is greater than the numerator. In both the sine theta and cos theta, the denominators are greater than the numerator. Because of that, the value of the sine theta and cos theta can never be greater than 1. So this is a very important concept. So let me note down here. So value of sine theta and cos theta can never be greater than 1. So this is really a very important concept. And the next one, that is note number B. Now sometimes we get confused. What will happen if I vary the sides of the triangle, sides of a triangle? Now let me remind you here, whether you are varying the sides of a triangle or not, as long as the angle remains same, the value of the trigonometric ratios never change. So you can note it down here. Value of the trigonometric ratios remain same as long as the angle does not change. So these are the concepts that you have to keep in your mind. So this is the end of the theory part of lecture 1. In the subsequent lecture, we are going to discuss some of the problem from NCERT text. So hope you have enjoyed the lecture. So if there is any problem regarding this particular lectures, so you are welcome to give your feedback. Thank you.